All right, guys, so this is our last Flip the Classroom lesson of Chapter 2. In this lesson, we're going to talk about solving rational equations. And for us, rational equations are going to be equations that have terms with polynomials in the denominators. And so we're going to be looking for the x values or the variable values that will make those statements true. First, what we're going to look at is just an equation with some fractions in it, right? And we're going to talk about some strategies for this equation that we can apply to rational equations. So right here, one thing we could do with this guy is just to get common denominators and then combine everything into one fraction and combine all the like terms in the numerator and then basically just solve the equation in the numerator. But perhaps an easier method for solving this equation would be to multiply on both sides by the least common denominator, which is the smallest number that has both denominators as a factor. So right here we've got denominators of 4 and 8, and we would say that the least common denominator would be 8. Since right here, obviously, 8 is going to be a factor of 8, and 4 is going to be a factor of 8. So 8 is the smallest number that has 8 and 4 as factors. Now, when we multiply by that 8 on both sides, what we're going to see is our denominators canceling out. When I multiply by 8 on this side, I've got a multiplication of 8 and a division of 4. Those things cancel, and I get a multiplication of 2, which is going to give me 6 times x minus 5. And right here, what we're going to have when we distribute that 8 into both of our terms is 8x, and then when we multiply 8 and 8/3, we are going to get plus 3. Now right here, we can go ahead and solve this guy. This is going to be 6x minus 30 equals 8x plus 3. And continuing on here, we would get the x's on one side and the constants on the other, so minus 6x, minus 6x, minus 3, minus 3. And that's going to give us, right here, negative 33 equals 2x, divide by 2, and we can say that x is going to equal negative 33 over 2, or negative 16.5. Now, right here, we have 1 over x plus 4 equals 5 over 3x minus 2. This is a rational equation because right here we've got polynomials in the denominators. One easy way we could think about solving this guy, though, is just by cross-multiplying, right? Since we've got two fractions that are equal to each other, one common method for solving for variables where we have two fractions equal to each other is just by multiplying by the denominators on both sides. So right here we would multiply 1 by 3x minus 2, and that would give us 3x minus 2. And then we would multiply 5 by x plus 4, and that would give us equals 5x plus 20. And again, right here we could just solve for x by bringing all the x terms to one side, so subtract 3x from both sides, and bringing the constants to the other. Oops, it's going to be 20. And then right here we would get negative 22 equals, and then 20x, divide by 2, and we can say that x is going to equal negative 11. Now, one thing we want to take note of right here, whoops, bring that guy back, move all this stuff over, is that right here, cross-multiplying is really the act of multiplying by the denominator on both sides, right? So really what I'm doing is saying x plus 4, multiplying x plus 4 on both sides, right? And I'm taking for granted that when I multiply x plus 4 on this side, right, it's going to cancel out with the denominator. So I just get the multiplication of x plus 4 on the other side times my numerator, 5. And similarly, right here, we're saying that if we multiplied by 3x minus 2 on both sides, that right here, that 3x minus 2 that we're multiplying on this side is going to cancel with a 3x minus 2 in the denominator. And again, we just get the multiplication of 3x minus 2 times 1 in the numerator over here. So in general, we don't want to think of cross-multiplying as just sort of coming out of nowhere. Really, it comes from multiplying the denominators on both sides. But since we basically are going to see those denominators cancel for both sides, then we can just sort of think about it as multiplying the numerator on one side by the denominator on the other for both sides. Okay, so let's talk about some other rational equations here. Solving for equations in one variable. So solving a rational equation, if f of x and g of x are polynomial functions with no common factors, then the real zeros of f of x are going to be the solutions of the equation And right here we would have f of x over g of x. And really what we're saying here is we've got one rational expression equal to 0, right? So basically the way we can think about this is a fraction is going to equal 0 when the numerator of that fraction equals 0. So right here, that means that this statement is going to equal 0 when we have 0 in the numerator, so long as we don't have a 0 in the denominator. And this is what we mean by no common factors. If right here, 5x minus 18 is a factor of the denominator, then we're also going to get 0 in the denominator and we'd be undefined. So right here, so long as the x value that gives us 0 in the numerator is not also giving us 0 in the denominator, we can take the numerator, 5x minus 18, and solve for the 0 right here. Just solve for x right here. That would be x equals, and then we would have 18 over 5, or 3.8 as a solution. Okay, so solving by clearing the fractions. Here we've got a rational equation that's a little more like the kind of rational equations we're going to look at more in this section. This is, of course, an equation where we've got more than one rational term, right? More than one term with a polynomial in the denominator, right? And our strategy here is going to be to clear out the denominators by multiplying by the least common denominator on both sides. Now right here, for our rational equations, we're going to say that the least common denominator is going to be the polynomial, right, that has the smallest polynomial, that has all polynomials as a factor. So in order to find my least common denominator here, the first thing I'm going to do is factor out all my denominators. So right here I'm going to have 5x, and then over x times x minus 3, and then plus 2 over x equals 2. Now my least common denominator is going to be the smallest polynomial that has x and x times x minus 3 as factors, and that would be x times x minus 3. This has x as a factor, and it has, obviously, x minus 3 or x times x minus 3 as a factor. So right here, we can take these guys away, and we can go ahead and multiply by that least common denominator on both sides, and get rid of the denominators for our rational equation. So right here, we're going to say we've got 5x over x times x minus 3 plus 2 over x times our least common denominator of x times x minus 3. And then right here we've got 2 times, and then this is going to be x times x minus 3 on this side. Now right here, we're going to distribute our x times x minus 3 to both of our terms here, right? In this first term, we're going to see the multiplication of x times x minus 3 cancel out with the division of x times x minus 3, and we're just going to get our 5x for this multiplication into the first term. And now when we multiply into the second term, we're going to see the x's cancel, because we are multiplying by x and dividing by x, so these guys are going to cancel. And we are going to get our 2 times the remaining linear factor, x minus 3, right? Now on this side, we can just do our multiplication out. Right here, we can say we've got 2 and then x times x minus 3, which is basically what we're seeing there with our multiplication. Now right here, we can go ahead and simplify both sides. So right here, I can say I've got 5x plus 2x minus 6 equals 2x squared, and then minus 6x, right? Right here, what we can see is that we've got a quadratic equation, so we can bring all of our terms to one side and see if we can factor or use the quadratic formula. So right here, I'm going to combine these like terms first. We've got 7x minus 6 equals 2x squared minus 6x minus 7x plus 6, and right here, minus 7x plus 6, and this is going to give us 2x squared, and then right here, minus 13x, and then plus 6 equals 0. So right here, can I factor this guy? Yes, I can. I can say that this is going to be 2x and x, and minus, and then right here, I can say that this would be, let's see here, we have 6 and 1. These are our 2 linear factors that multiply to give us this quadratic, and then we can get the zeros of 1/2 and x equals 6. Now right here, what I'm going to need to do is check these answers, right? So immediately, we've got 2 answers, right? And we want to check them to sort of make sure we're doing our math correctly, but we also want to check them I need to slide this over. Let's see if we can do that again. slide this over. So right here, we also want to check them to make sure we don't have any extraneous solutions. And we'll talk about that in a second. So right here, I'm going to check to see if these are actual solutions by plugging them into my original equation. So right here, I'm going to have 5 times 1/2 over, I can say 1/2 times 1/2 minus 3. I'm going to plug it into this form with a factored denominator. I think it's going to be a little bit easier to deal with the denominator there rather than squaring that fraction. And then plus 2 over 1/2 equals 2. So now right here I've got 5/2 over, and then this is going to be 1/2 times, this looks like it's going to be, that's going to be 3, which is going to be 6/2, so that's going to be minus 5/2, so this is going to be negative 5/4 when we multiply those guys. And then plus, and then this guy I can multiply by the reciprocal with and get 4 equals 2. Now right here I can multiply by the reciprocal of that negative 5/4 and get right here 5/2 times my negative 4/5 now, plus 4 equals 2. And these guys, the 5s are going to cancel when we multiply those two fractions, and we are going to get negative 4 over 2 plus 4 equals 2, which is going to give us negative 2 plus 4 equals 2. And that's true, so we know that x equals 1/2 is going to be an actual solution for us. Now right here we can do the same thing with our 6. So right here, plugging this in, we can say we've got 5 times 6 over, and then this would be 6 times 6 minus 3, and then plus 2 over 6 gives us 2. So this is going to be 30 over, and then right here we can say 6 minus 3 is going to be 3, times 6 would give us 18. Oops, 18 is a little weird there, that's okay. And then right here we've got 1/3 equals 2. Now I can reduce that to 5/3 plus 1/3, which would equal 6/3, which does equal 2. So this is actually a solution as well, right? Now, obviously I want to check this just to make sure I did my math right. That's always a good idea to check your answers for that reason. But also, when we multiply by a least common denominator on both sides, there's the potential of what we would call an extraneous solution, or an x value that would not make the statement true. So that's also something we're going to need to watch out for when we're using this method of multiplying the least common denominator on both sides to clear out our fractions or our polynomials in the denominator. So right here, what I want you guys to do is to go ahead and give this one a shot. You can pause the video right now, and we will look at this together in a second. Okay, so we've gone ahead and set this up a little bit. First thing I did was to factor this quadratic in my denominator to see what linear factors it was made up of. And right here what I can see is that it's made up of the same two linear factors I've got for both terms over here. I'm going to take all this down. I think that's a little more confusing than I'd hoped it would look. And then we'll re-imply it in a second. So right here, basically what I can see is that my least common denominator is going to be the polynomial x plus 1 times x minus 2, because that is the smallest polynomial, the polynomial that we are multiplying the least linear factors for, that gives us all of the polynomials as factors. So right here what we can now do is multiply that least common denominator on both sides. So we're going to go ahead and do that. Multiply our x plus 1 times x minus 2 on both sides, and it's going to cancel out our denominators for us. Right here on the left side, when I distribute through that least common denominator, it's going to cancel differently with both my terms. When I multiply into the first term, I'm dividing by x plus 1, so that's going to cancel the x plus 1, and I'm just going to get 3x times my x minus 2. So right here we'd get 3x times x minus 2 when we multiply into the first term. Then when I multiply into the second term, what I'm seeing cancel is my x minus 2, right? Since right here we are multiplying by x minus 2 and dividing by x minus 2, that's what's going to cancel there, and so we're going to get plus 5 times the linear factor x plus 1. When I multiply on the right side, I am multiplying by x plus 1 times x minus 2 and dividing by that, so that cancels out altogether, and I just get 15. Now right here, we can simplify this side. We can see that we're going to get a quadratic equation here when we multiply through. And so we're going to want to bring all of our terms to one side and see if we can factor or maybe use the quadratic formula. So right here, I'm going to minus 15 and minus 15. And this is going to be 3x squared. And then right here, this is going to be minus x and then minus 10 equals 0. Now right here, when I factor this, all right, if I can factor this, we can see that we can actually factor this. So that's going to be 3x and x. And right here, I'm going to get, let's see here. This is going to be 2 minus 2 and plus 5, right? And that's going to give us the solutions of x equals negative 5/3 and x equals 2. Now we want to check these. And right here, we've talked about the method of plugging this in. That's what we're going to do here again. There are other ways to check, though, and one of the things we can also do is incorporate our calculator to help us do this a little bit quicker. So right here, we're going to plug all this in. We're going to plug in our first solution right here, negative 5/3, into our original equation. Right here, that'll give us 3 times a negative 5/3 over negative 5/3, and then plus 1. And then plus, and then we can say 5 over negative 5/3, and then minus 2, and then equals our 15 over negative 5/3. And this is going to be, again, I'm going to plug it into the factored version of this, right? So right here, we're going to say, pull this out of here. 15 back. And right here we can have this as plus 1. So negative 5/3 plus 1 times negative 5/3 minus 2. So right here what I would say is in the end, you know, it's nice to be able to do all this fraction simplification out, but I am fine with you guys giving me numbers in the calculator. So if we evaluate this guy, this first guy, we get 7.5, and then plus, and then this next guy is going to be a negative, and then right here we've got 1.36 repeating, and then that's going to equal 6.136, where 36 is repeating. Now, right here, this doesn't help us out that much, but one thing we can do is to go back to Math Frac and see if we can get these to look a little nicer, maybe by representing them as fractions. And when we do that, we get 15 over 2, and then minus, let's say, 15 over 11, and then equals 135 over 22. So by getting common denominators here, we can say we'll multiply 15 by 11 here and get 165 over 22. And then minus, we multiply the numerator and denominator by 2, we get 30 over 22 equals, and then right here we get 135 over 22. And that one works out. That's a solution. So again, I think if I ask you something like this, I'm going to ask you to check for extraneous solutions, but you can do that in the calculator and sort of save yourself the extreme amount of steps that it would take to actually determine if it would be true. Now right here, what we want to do is check our second solution. So plugging in 2 into our original equation, and again, I'll plug it in right here. is going to give me 3 times 2 over 2 plus 1, and then right here plus 5 over 2 minus 2 equals, and then right here we've got 15 over 2 plus 1 times 2 minus 2. So right here we've got two big problems. 2 minus 2's in our denominator mean that we're going to get 0 in the denominator here and here. So that means that we're going to have two undefined terms here, and this guy right here, x equals 2, cannot be a solution for us. So this is an extraneous solution. Solution. Right? We found an x value that did not turn out to be an actual solution for our rational equation, for our rational problem there. So right here, moving on, we want to look at situations where we're not necessarily going to get rational numbers as solutions, and determine what we're going to do there. So right here, we've got x plus 1 over x minus 4 equals 0. And right here, the least common denominator is going to be the only denominator in this case, x minus 4. And right here, when we multiply by that x minus 4 on both sides, we are going to see a quadratic come for us. So right here, multiplying on the left side, we distribute, and we distribute x through x minus 4, and that gives us x squared. And then right here, minus 4x, and then we distribute to our second term. The x minus 4 that we're multiplying is going to cancel out with that x minus 4 that we're dividing 1 by. And right here, we would just get plus 1, and then this is going to equal 0. So pretty quick work here. On the other side, obviously, anything we multiply by 0, we get 0 for, so that's going to give us 0 there. And now right here, what we're going to see is that we've got a quadratic that we cannot factor. So what we're going to have to do is use the quadratic formula. Now, when we use the quadratic formula, we're going to say a equals 1, b equals negative 4, c equals 1. And right here, for our quadratic formula, that is going to give us x equals, and then a negative 4, plus or minus the square root of that negative 4 squared minus 4 times the a term of 1 times the c term of 1, all over, and then 2 times the a term of 1. So right here we can simplify this guy and solve them out. So we get 4 plus or minus, and then this is going to be the square root of 16. I'll write that again. Square root of 16. And then right here we've got 1 times a negative 4, so minus 4, over 2, which is going to give us 4 plus or minus, and then this is going to be the square root of 12 over 2. We can simplify this guy a little bit. We can say he's 4 plus or minus, and then right here we would have the square root of 4 times the square root of 3, which would give us 2 times the square root of 3. And then right here we can say that our two solutions are going to be x equals, and this is going to be 2 plus the square root of 3, and x equals 2 minus the square root of 3. Now right here we can say that these solutions would be approximately, and then 3.732, and right here we could call this guy approximately 0.267, we'll call it 9. Now right here, plugging these guys back into the original equation to see if they give us solutions is a messy process. So one thing we can also do to check to see if our solutions are both valid is to change our equation into a function, right? Type it into the calculator, and since it equals 0, right, since our equation equals 0, we can see if this function, right, has x-intercepts that correspond to these solutions right here. So taking out our calculator, we would plug in right here x plus 1 divided by x minus 4, and then graph that guy. That gives us this graph right here. We're seeing two x-intercepts that look pretty good, right? So right here we can go ahead and find those zeros by going to 2. And right here we would want to go a little to the left and a little to the right, and then press enter. And right here, there's our 0.2679, right, 4919, right? And right here, we can go back and check the other 0 to see if it represents our other solution. And we go all the way over. We go a little to the left, which in this case is going to be above the x-axis, a little to the, oops, that's a little far to the right. So right here, a little to the right, hopefully that's enough. Press enter, and then enter again. And right here, we've got our 3.732. So both of these turn out to be valid solutions for our rational equation here. Now, right here, you guys can go ahead and give this one a shot. This turns out to be one video, I guess. So right here, it's one video. Hopefully, it'll be about 30 minutes long when we do the whole thing. Why don't you guys go ahead and pause the video and give this one a shot, including checking for the solutions, and we'll come back and look at it in a bit. So looking at this one, we find that the least common denominator, after we factor out our quadratic right here, is x minus 3 times x minus 2. We multiply that guy on both sides. Here he's going to cancel out with the entire denominator, and when we distribute him through on this side, we're going to get the quadratic times 2, right, which we can represent right there. And then when we distribute him to the second term, we're going to see the x minus 3 cancel out, and it's just 1 times x minus 2, which you can represent right there. Now, simplifying, we can get down to this quadratic right here, 2x squared minus 9x plus 7. And then at this point, we can actually factor this guy. So right here, we can get these two zeros, 3.5 and x equals 1. Now, one thing I would point out here is that another valid way for checking extraneous solutions here is always going to be, can I represent this guy as a function, right? Can I represent this guy as a function and then find his zeros? And we can do that by subtracting this term from both sides, right? And then typing them into the calculator. So right here, if I subtract my 3 over x squared minus 5x plus 6 from both sides, I get 2 plus, and then 1 over x minus 3 minus 3 over x squared minus 5x plus 6 equals 0, which is, of course, going to give us the function y equals 2x plus 1 over x minus 3 minus 3 over x squared minus 5x plus 6. And this guy right here we can type into the calculator. And when we type him into the calculator here, we get the graph that is crossing at 1 and at 3.5. And you could find those zeros the same way we did before. But so right here what we're seeing is both of our zeros turn out to be solutions for our equations, so they both work. Okay, I'm going to give you guys one more to try, and then we're going to call this one right here. Why don't you guys go ahead and give this one a shot, and we'll come back and look at the solution real quick. Okay, so right here we can see that by factoring our quadratic, we get x minus 1 times x minus 3 in the denominator. And since those are both the denominators of our two terms on the other side, we can say that our least common denominator is going to be x minus 1, x minus 3. When we multiply that on both sides, we're going to see the multiplication and the division cancel on this side, right? And when we distribute that multiplication through to both of our terms here, in our first term, the x minus 1's cancel and give us the multiplication of 2x times x minus 3. And in our second term, we see the multiplication and the division of x minus 3 cancel, and we get the multiplication of x minus 1, and that equals 1, right, which was our numerator on the other side. So right here, at this point, we can simplify this guy. We're going to get down to this quadratic right here. We can't factor this guy, so what we're going to do is use the quadratic formula, and when we use the quadratic formula, we come to the two solutions we're seeing right there, these two irrational solutions, which give us these approximate x values as solutions to our rational equation. Now, if I take my original equation here and set him equal to 0 by subtracting 1 over x squared minus 4x plus 3 from both sides, I can turn him into a function y equals, right? Type this guy into the calculator and see if I come up with these two solutions as x-intercepts. So right here, taking up my calculator, type this guy in, right? And then when I graph them right here, I've got x-intercepts that look like they're pretty accurate, and we can test them out by finding what they are, finding those zeros. So right here we'd go 0, let me go a little to the left with the left bound, press enter, go a little to the right, below the x-axis, press enter again, and I'm coming up with my negative 0.3507, so that's approximately what I got right there. And then second, trace calc again, and then of course the 0. So right here we'll arrow over to that other guy. And again, we're a little to the left first, press enter. You need to cancel that, whatever that is. And then right here, we'll go a little to the right, so a little below it, and press, let me go on the other side. And I can press enter again, enter one more time, and right there I'm getting my other 0 pretty accurately at 2.8507, which we could round to 2.850 or 2.851. So right here, that's the lesson, guys. We'll go ahead and do a worksheet when we get in tomorrow. It's a little shorter, even though it was one video, longer video. But again, you guys can sort of fast forward this as you want, and then we'll look at this tomorrow. All right.